Hello, students. And here we are, topic number 13. And our topic this week is erosion and deposition. Erosion and deposition. As you saw from our video yesterday, you can't have one without the other. They go together, erosion and deposition. So we're going to be talking about these as individual words, but I want you to remember throughout this topic that you can't have erosion someplace without deposition someplace else. So let's get right to our notes at this time and begin with the word erosion. Erosion can be described as the movement of particles from place to place. The movement of particles from place to place. And you can see here that there is a little agent of erosion up on top of the E for erosion. Our little friendly bird here is pecking away at the letter E, and it is causing little bits and pieces or particles to move from up here to down below. We call that erosion. But as we said, erosion can't happen without deposition. And deposition can be described as the settling of particles in a new place. So whenever you have erosion, the movement of particles, you're going to have those particles settling down somewhere. Typically, they settle down in nature. They settle down somewhere where there is less energy. It takes energy to weather materials in order to allow them to be eroded. It takes energy to do that. And when that energy is released and it is allowed to settle down from an energy standpoint, then the particles will settle out as well. Think of a roaring, raging river. You've got a roaring, raging river at the end of a rainstorm. That water turns dark and soupy with all of the sediment because of the energy of that water flow. And at the end of that river, maybe even the mighty Mississippi, you've got a huge delta where the river water is not going nearly as fast anymore, and you've got the settling out of those particles. But nonetheless, we've got erosion and deposition always working together. Now, let's mention today that there are 5 agents of erosion. And when we talk about agents of erosion, we're not talking about Kim Possible or Sherlock Holmes or Bond, James Bond, not those types of secret agents, but we're talking about factors, things that can happen that cause something else to happen. So let's begin with number 1. We'll list them and then we'll go through them in a little bit more detail. So the first agent of erosion is gravity. In fact, you might even say that gravity is the root cause of erosion, no matter what agent of erosion you're even referring to, because gravity is a force that exists throughout our planet. And every time something is eroded, gravity is going to pull it down. But in and of itself, gravity is a major agent of erosion as it pulls massive piles of debris downward. We'll talk more about that later. Number 2 is wind. As the wind blows, if you've ever been in a windstorm, no matter where you live, if you've experienced a windstorm, you may have gotten particles in your eye or in your face, and they could hurt. Well, think about the wind picking up little particles, little debris, like little pieces of stone, little pebbles and sand. Think of the beach. Oh, here's a good example. Think of the beach. And you've been spending the whole day at the beach. You're ready to leave. but somebody else is ready to leave. They pick up their blanket and shake their blanket out. How rude. And chances are it's probably windy, and that wind blows the sand right in your face. And oh, it's just awful. It feels gritty. It's like sandpaper. Well, as wind is blowing these particles around, it is like sandpaper, like sandblasting. And you can sandblast holes through rocks like this. Number 3, water. Perhaps one of the biggest, most recognizable agents of erosion. Water, as it runs along the surface of the ground, is one of the major agents of erosion. And in this case, we're talking about liquid water, in contrast to number 4, which is ice, which is also moving water. It's just in the frozen form that we call glaciers. And glaciers can be either continental glaciers or valley glaciers. We'll talk about the difference between those two later on. And that brings us to number 5. The 5th agent of erosion are the waves. 3/4 of the earth is covered in oceans. Only a quarter of the earth is covered in land. So waves are constantly crashing against the surface of our land shorelines every moment of every day of every year. There's a lot of erosion that takes place along every continent's coast, and that is due to the waves. Again, a lot of energy. In all of these 5 agents of erosion, there is always a source of energy that facilitates or causes the erosion to take place. So there we have it, the 5 agents of erosion, but let's now unpack them a little bit more in detail. But before we do, I almost forgot, there are some other agents of erosion that are less common. Biological activity is an agent of erosion. In fact, we mentioned in the first unit how geologists are currently thinking about adding another geologic era to Earth history due to the impact that human beings are having on the erosion of our landscape. There are places, maybe in class I'll show you a picture of West Virginia, where we have completely removed entire mountains in order to mine coal, for instance. We are altering the landscape, and so we are an agent of erosion. But before humans even existed, there were other animals like the animal that created this mound in Africa. This is a termite mound. Other organisms, both plants and animals, including insects like termites, can have a pretty significant influence on eroding materials from the earth. We call all of these things biological activity. Biological activity as an agent of erosion includes all plants, animals, and yes, humans as well. But going beyond that, there is one other source of erosion that we can think of, and that is from E.T. E.T., go home. E.T., which stands for extraterrestrial. Extraterrestrial material. Things that are beyond the Earth. For instance, this picture here of Meteor Crater in the southwestern U.S. was a very quick erosion of the landscape by an asteroid, or a meteor, I should say, meteor that came through the atmosphere and landed as a meteorite and eroded an enormous amount of land in a very short period of time. So in addition to the 5 major ones, we can add these 2 others, biological and extraterrestrial. But by and large, for the vast majority of Earth's geologic history, those 5 agents of erosion are things that we visibly can observe within the course of a human lifetime. All right, so let's start unpacking them now, beginning with gravity. Wow, check out these 2 pictures. The one on the left here is showing what's called a landslide, an entire portion of a hill, probably because of increased moisture content. And this happens very frequently on the West Coast, parts of California. This happens periodically where entire hillsides will literally wash down a slope pulled by gravity in a way very similar to what happens on the tops of mountains that are covered in snow. Here we have an avalanche of snow. In fact, this snow in an avalanche can travel well over 100 miles an hour, pulverizing everything in its way, including trees and people. So we've got some examples of how gravity can pull things down, and together we call it mass wasting. Mass wasting is the downhill movement of sediments. It's the downhill movement of sediments, and those sediments move downhill due to gravity. Now, not all mass wasting is the same. I gave you a couple of examples already, and just to articulate them in a list, we've got landslides, mudslides, and avalanches. All of these are examples of how gravity can move a massive amount of material, particles and larger, in a short period of time. In other words, erode the landscape. So gravity, our first major agent of erosion, can cause landslides, mudslides, and avalanches. All right, that brings us to number 2. Our second major agent of erosion is the wind. Now, when we talk about wind erosion, you may see in books, wind erosion is also referred to as aeolian. Aeolian is a fancy term which means wind. Aeolian. Aeolian features or aeolian processes are simply another way of referring to wind erosion. So let's talk about wind erosion or aeolian features. The first thing to keep in mind is this connection between erosion and deposition. We're going to see that here with wind erosion. There's a word called deflation. It has nothing to do with the economy and inflation and deflation, but in the context of erosion, deflation is the movement of loose material. And when we talk about loose material, we're referring specifically of particles of soil, clay, silt, and sand. Clay is much finer, much smaller than silt, which is smaller than sand. If we look at this diagram here on the left, we can see how wind, indicated by the red arrow, is blowing from left to right. Larger particles like sand will move closer to the surface. Smaller particles like silt can actually travel higher above the ground. Really small particles like clay can actually be carried up into the upper atmosphere and travel thousands of miles. In fact, much of the silt and clay that is picked up by winds in the Sahara Desert in the continent of Africa are carried all the way across the Atlantic Ocean and deposited in South America, over the tropical rainforest. Many of the minerals and nutrients that are needed by the life forms in the tropical rainforest are deposited from eroded particles from thousands of miles away. It's really pretty fascinating to think about how interconnected our planet Earth is. Now, this picture over on the right-hand side is what is referred to as a sandstorm. Sandstorms can happen in the desert, and as we mentioned in the diagram on the left, the sand really is close to the ground. It's probably more like a silt storm, blowing the silt in your face and the sand on your feet. But either way, you don't want to get caught in what's called the sandstorm because it can blind you. And those particles, no matter how big or small, when they're being blown by ferocious winds, it can be very painful indeed. It can erode your skin off your face if it's bad enough, believe it or not. All right, so again, as the diagram was explained, small particles are carried farther than the larger particles. And you know what? This is also true in streams, if you think of streams, and we'll get to running water in a little bit, but streams, the smaller particles are going to be carried a greater distance than the larger particles will be. Same thing with wind. In fact, many scientists consider wind and water both to be fluids flowing from one place to another, even though most of us probably think of fluids as just being liquids. All right, moving on. Abrasion. Have you ever felt sandpaper? Ooh. Or a nail file? Ooh, I hate that feeling actually, but I use sandpaper when I'm working on wood projects. And when you use sandpaper, you are rubbing the surface of the wood and you are wearing away the wood to make something smoother. Well, over time, wind picking up these particles, whether they be sand, silt, or clay, and blowing in the wind can act like sandpaper. It's called abrasion. Abrasion can literally wear away and blast away rock that is exposed on the surface. This arch here is an example of wind blowing right through solid rock. Now, it doesn't happen all at once. It happens over time, but blowing wind that is carrying small particles can literally wear away the surface of rocks and statues, for that matter. Things that are made by humans can be worn away, eroded away, undergoing abrasion due to the wind. As we keep on saying, you can't have erosion without deposition. So let's mention a few things about wind deposition. Probably the most famous feature of all deserts in the world are sand dunes. Dunes are mounds of sand that are deposited by the wind. Here on the east coast of the U.S., we've got a few notable locations with really big dunes, sand dunes. North Carolina and the Outer Banks comes to mind. There are huge sand dunes there that are piles of sand deposited by the wind so tall that people actually jump off of them with hang gliders and fly. There are incredible sand dunes on the West Coast, in Oregon, near the Great Lakes. I think there's a sand dunes national park near one of the Great Lakes. Maybe it's Lake Superior. I'm not quite sure about that. I think it is. But we can find sand dunes not just in deserts, but in other ecosystems as well. But no matter where you find a sand dune, and no matter how big or small, even if it's on the beach at the Jersey Shore, little itty bitty sand dunes are mounds of sand deposited by the wind. Now, another feature caused by the deposition of particles blown by the wind are called loess deposits. Loess. Loess deposits. These loess deposits are fine sand and more primarily silt particles, are particles smaller than sand, deposited in layers far from the place of origin. A notable feature in North America would be the Great Plains. The Great Plains are areas with very significant loess deposits left over from the last ice age. As the last ice age was receding or warming up, it left behind large deposits of sand and silt. And due to the primary direction of wind back in those days, a lot of those silt deposits were eroded by the wind and then deposited elsewhere, a lot of it in the Great Plains, which makes the Great Plains a very fertile area for grass species. The Great Plains are known for their short grasses and their tall grass species. So we've talked about a lot here today, actually. We've listed the 5 major agents of erosion. We unpacked in a little bit more detail the first 2, gravity and wind erosion, as well as deposition. And so I think we'll save our next one for tomorrow because the next one is rather large. It is a significant agent of erosion. We'll pick up tomorrow with running water. So until tomorrow, I will say bye bye.